Hi folks, today we're going to learn about two topics, and this is your last video for chapter 5. First one is looking at what's called oxidation numbers, and basically those are the ions that are going to form when an atom forms an ionic bond, whether it's a positive ion or negative ion. The other one is just a brief overview of the periodic trends and what happens to the trend as you go across the period and down a group. First of all, atoms must fulfill the octet rule, which means in order to be stable, they have to have a filled outer energy level. They can obtain that by either gaining electrons or losing electrons. We call those oxidation numbers. What electrons will be added or removed to make an atom more stable? We already know from the other day that group 1 has one valence electron. So we're going to look at what happens to the metals when they form ions and the nonmetals when they form ions. First, we're going to focus on the cations. Cations are positively charged. We've talked about this before. They are going to lose electrons, and if you lose a negativity, you become more positive. These are the metals. So we're talking about groups 1, 2, 13, some of the ones in the lower P block, and then all of the transition. We're going to leave the transition for another time, though. So group 1, we know, has one valence electron. Well, its options are to either lose 1 or gain 7 to obtain that octet. The easiest thing for it to do is to lose 1. If it loses 1, it's going to become more positive, and we'll have a +1 charge. Normally, we don't write that 1, we just write the plus, but for purposes now, I just want you to understand that that is a +1 charge. Group 2, when we did the Lewis dot notation, you know that group 2 has 2 valence electrons. It will then have two options, either to lose 2 or gain 6. In this case, it's going to lose 2. Our metals are going to lose. When it loses 2, it becomes more positive by a +2. We're going to skip all the transition metals and go to group 13. We used aluminum as an example in group 13, and it had 3 valence electrons. Its options are to lose 3 or gain 5. It's going to lose 3. When it does that, it's going to have a +3 charge. As far as the cations, those are the 3 groups we're going to focus on. So now we're going to go over to the anions. These are the negative ones. These are our nonmetals. These are going to gain electrons. They have a really good ability to gain electrons. Starting with group 17. They have 7 valence electrons, if you recall. Their options are to lose 7 or to gain 1. It's going to be a lot easier for it to pull an electron from another atom than for another atom to pull 7 from a group 17. So they're going to gain 1 electron. When they do that, they become more negative. If you gain a negativity, you're going to become more negative. So they're going to gain 1 electron and become more negative. It's a -1 charge. You'll see just usually a minus charge. Group 16, they have 6 valence electrons. Their options are to either lose 6 or gain 2. It's going to be easier for them to gain 2. Therefore, if they gain 2 electrons, that's gaining 2 negative charges. So they're going to be a -2 charge. And then the group 15 has 5 valence electrons. Their options are to lose 5 or gain 3. They have a better ability to gain 3. So if they gain 3 negatively charged particles, they're going to be a -3 charge. Moving on to the last topic in chapter 5, you should have already taken notes on the periodic trends. If you haven't done so, your directions today say to go and do that. So just 3 common trends. What happens to size, electronegativity, and what's called ionization energy. So what happens to the size of the atom and the size of the ion as you go down a group? Well, it's going to increase. What happens to the size of the atom and the size of the ion as you go across a period? It's going to decrease. It gets smaller because the nucleus has a better ability to pull in the electrons. The next one, as you're going down a group, electronegativity decreases. Electronegativity is how well can an atom gain an electron? Well, francium's very, very bad at it because its electrons are so far away from the nucleus. As you go across, those atoms become very good at it. The best one on the periodic table is francium. I'm sorry, fluorine. I take that back. Fluorine. Fluorine you can consider the god or goddess of the periodic table. Everyone is attracted to fluorine. So they have a very good ability to attract electrons. Francium, on the other hand, has a very bad ability to attract electrons. Then the last one is called ionization energy. As you go down, it decreases. What that means is how easy can an electron be removed from an atom? And I misspoke earlier when I was talking about francium. This is where we're talking about francium being, you can take an electron very easily from francium because the electrons are so far away from the nucleus. And that's what that means. It's very easy to remove an electron from francium. It's going to be very, very difficult to remove an electron from, say, a halogen or a noble gas. Noble gases, it's practically impossible to get an electron away from them because they are already an octet or stable. If you have any questions, check in with me later. Thanks.